Welcome to Module 8, the second section, which is actually 4.1 graphs and functions. So some more definitionary stuff in here. We're going to actually define a new type of notation and some other things. So a function is a correspondence between a first set, called the domain, which are the input values, and a second set, called the range, which are the y values or output values, such that every x corresponds to exactly one y value. So what I want to do is actually come down here to are these a function now and talk about that. Now, this x would be our domain set, our input values. These y's would be our ranges. So we could think about these kind of as ordered pairs. In fact, we could think about this first relation here giving us these ordered pairs here. We'd have 1 comma d. We would have 2 comma c. And then finally the last one we would have 3 comma c. Now this is a function because every x value corresponds to exactly one y value. The y value doesn't need to be unique, like here, two things go to c, but that's totally fine. Now if we look at the second relation over here, right here, these are our x values, these are our y values. If we look at what's going on with this, well, we could see these ordered pairs. We have 1 comma d, we'd have 2 comma b, and we'd have 2 comma c. Now this is not a function because we have one x value that corresponds to two different y values, and that is not a good thing when we're talking about functions. So over here, yes, because each x corresponds to exactly one y. Here, no, because each x does not correspond to one y. 2 actually corresponds to two different y values. Okay, so that is kind of what a function is, and we'll talk about this a little bit more here in a second. Now, a relation, you'll notice here, is like a function, but each x value corresponds to at least one y value. So like this over here, it's not a function, but it's a relation. This over here is both a function and a relation. Okay. So with this new notion of what a function is, there's notation that is going to accompany it. And the notation for the function is this. F, and then in the parentheses we have the x, and it reads f of x, or f evaluated at x. So if we think about the way that we used to denote things, we could have y equals 2x plus 3. Now what we're going to have is f of x equals 2x plus 3. And it's easy for evaluative purposes to write in this new notation. But notice, if y equals 2x plus 3 and f of x equals 2x plus 3, well, 2x plus 3 equals 2x plus 3, so f of x actually equals y. It's our new y. It's a new way of writing y. So, if we have this function here, f of x equals 2x plus 3, we could ask the question, what is f of 2? Well, that's asking, what is the function value when x equals 2? So notice, the difference between this right here and this right here is, here we have f of x, here we have f of 2, so there's a 2 where the x should be. So what that tells us is, over here in the definition of the function, wherever there's an x, we're going to write 2 as well. So f of 2 is nothing more than 2, and then we plug our 2 in for, geez Louise, then we plug our 2 in for x plus 3. Seems to me that's not writing well. 2 times 2 is 4, plus 3 is 7, so f of 2 is 7. And what this corresponds to an ordered pair. When x equals 2, y equals 7, so it's the ordered pair 2, 7. Okay. Now we could ask, what is f of negative 3? Well, f of negative 3, same thing. Wherever we see an x up here, now we're plugging a 3 in. We're just going to plug the 3 in, so this is 2 times negative 3 plus 3. 2 times negative 3 is negative 6, plus 3 is negative 3. So f of negative 3 is negative 3. So the function value when x is negative 3 is negative 3. This corresponds to the ordered pair. Let me erase some of this to get over here. That's going to correspond to the ordered pair, negative 3, negative 3. Now, notice, this says f of pound sign. And it doesn't really matter what's in the parentheses. The rule of function notation is whatever's in the parentheses is going to go in for the x the way it's defined in this statement over here. Now, So f of pound sign, or hashtag, is nothing more than plugging it in. So 2, plug that in for the x, hashtag plus 3, and that's what it is. I don't know what that means, but the rule is plug that in for x. And f of hashtag plus dollar sign, it doesn't matter what hashtag plus dollar sign is. The rule says that we're going to plug that in for the x right here, so this is 2 times hashtag plus dollar sign plus 3, because the rule up here says whatever the input is, first thing we do is we multiply by 2, second thing we do is add 3. So this is how that is defined right there. So there's a test for a function, and it's a visual test to determine if something's a function. It's called the vertical line test, and the vertical line test essentially states that if a vertical line can be drawn through the graph, and if it touches the graph of anything more than once, then that's not a function. Now notice here, in the picture we have right here, we have this line. Because every vertical line that we could draw on this thing only touches that once, at most once, that is the graph of a function. If it touches it more than one, it is not a function. And notice from back here, we said that this is not a function. Well, we could think about graphing this. Let's say this is 1, and let's say this is 2, and let's say this is 3, and so on and so forth. And let's say up here we have A, and this is B, and this is C, and then this is up here is D. We have 1 comma D, so we go to 1, D, that's our point 1D. We have 2B, 2B, that's our point 2B. And we also have 2C, which is right here. 2C. Now notice, if we draw a vertical line right through this point right here, it touches the graph, or just ordered pairs we have here, more than once, hence this relation is not a function. And we'll look at more of these in the next part of the video.